If you've been following me on social media recently, you may have seen that I undertook the Global Wind Organisation's Basic Safety Training Programme, which involved working at height and manual handling, sea survival, first aid, and fire awareness. Now, this wasn't just a personal challenge for fun, this was part of an ongoing process to get Harmer Visuals as a production company ready and viable to be a service provider to go out and film on location in high-risk environments like wind farms and solar farms. You have to do training and certifications and all kinds of other paperwork before you can step foot in those environments and film for a client. So this episode of CleanTalk is released in conjunction with the full training vlog that's coming out this Friday. And in that film, we're going to dive into the full experience that I had doing the course, why it matters, and what it takes to be on the front lines of wind farms on and offshore across the UK and beyond. In today's conversation, we're going to sit down with Iain Tindall, who's the owner of the training centre where I undertook the course. Iain is a really experienced course instructor, and he also has years of experience in rope access and technical roles all across the globe. We talk about what good safety training actually means out in the real world, how risk is managed offshore when conditions are unpredictable, why complacency is one of the biggest dangers facing the industry at the moment, and why the training itself needs to evolve as turbines do too, growing bigger in size, being placed further offshore, and just generally, on the whole, becoming more complex. Quick note for audio-only listeners, this episode does contain excerpts from the full vlog, and so while you will get value listening to it, for the best experience, head over to YouTube or Spotify, where you can watch it instead. This conversation will be especially relevant to you if you work in offshore wind, operations, safety training, or engineering. But it'll also be of benefit if you're just curious to know about how we keep people safe while we're building the energy systems of the future. Let's get into it. Okay, Iain, thank you so much for joining me. Do you want to just give a quick bio?
My name's Iain, and I have run Belay Rope Access since 2013. Before that, I worked in the offshore oil and gas industry and the wind industry, doing rope access, cable changeouts. I was an industrial radiographer and a non-destructive testing technician. And I worked offshore for about 10 years. And before that in construction and general maintenance, using ropes. Working at height is obviously my passion. It's given me a brilliant career working all over the world. But one of the reasons I started Belay was just simply because I love teaching. I've always loved teaching. I was at one point a primary school teacher, and I wanted to really push the concept of safe working at height. I've been doing this a long time, and I've lost 3 good friends doing it in this industry. And I want to stop that from happening again to other people. And one of them was a trainee of ours, sadly, who died in 2017. It keeps pushing me on to make the training better so that we can send people out into the big bad world with the tools and the blueprints to keep themselves safe. They are the only ones who can keep them safe. You can't rely on some safety officer or risk assessment or anything like that to keep yourself. You are your risk assessor. You are your safety officer.
We're going to start off with the working at heights and manual handling.
You're the rescuer, go and rescue him, yeah?
First things first, I buckle in my work positioning belt, so my hands can be free for what's next.
Okay, yeah, good.
Then I get the controlled rate descender ready to connect both me and the injured.
We're now raising both you and the casualty.
I pull the rope through the descender to capture the progress and loosen up the casualty's anchor. Then I release their anchor and away we go. We're working here, we're getting a taste for what it's like out there, but obviously it's a whole different ball game when you're really on top of a turbine or doing any maintenance in infrastructure. Yeah. Unpack that for me.
Well, the manual handling is it's often seen as a bit of an afterthought actually, but it is a really, if you look at statistics, that is the thing that is going to take people out of work. That is going to take people out of work for a month, 6 months. Once you get to my age, then you will have had and experienced some kind of manual handling injury, whether that's a sprain or a strain, or my knees sometimes can play up a little bit. I've had problems with them in the past. I've had physio, looked at operations, but that's really because of what I've been doing for the last 27 years, which is climbing ropes and climbing ladders and various other things like that, kneeling down a lot. on cold, hard surfaces, on grating and things like that. I always wear knee pads now whenever I go out and do work. It's really crucial. So, doing things like that, when you're teaching manual handling, quite often, or when I see other people teaching manual handling, quite often it'll be in a classroom and you've got to pick a box of paper up and move it from one side of the room to the other or something like that. But in a turbine, you're in a confined space. So you're going to be potentially moving objects up to maybe 20, 30 kilos, even a 5 litre tub of fluid, lubricating fluid or something like that. It's about teaching the principles of doing that safely as possible. That's really what this is all about. It's about dynamic risk assessment. And that's what I've always tried to instill in the instructors and in all of our trainees, is that you can't make this job or whatever job you're doing 100% safe. You cannot. If you want to be completely safe, then all you have to do is not get out of bed in the morning. And then you've got other problems, of course. But seriously, you have to understand that there are hazards in this job and there are risks. So what we're trying to do is to obviously teach people how to minimize those risks, but how to actually do the job, get the job done. Yeah. Because you can say, well, that's a bit of manual handling. That's more than 10 kilos. I can't lift that. Well, if you're 25, 30 kilometers offshore, 100 meters up in a wind turbine, are you really going to stop there, go back, spend thousands on getting a piece of equipment to lift that little object? Or are you going to do a dynamic risk assessment? Are you going to say, okay, well, if I clear that space over there, if I position my body in this way, then, or maybe even, get someone who's bigger and stronger, perhaps, to do this job or to get it in the right position, or help me, or do something. Use some of the equipment on me, some of the tools that I've got on me, some of the ropes and pulleys that I carry with me as a technician. Yeah. Can I do this job? Because when it comes down to it, this industry is about producing energy, producing electricity to feed into the grid. And if a turbine's down for another day, well, that could be, off here, that could be maybe £100,000 lost per day, per turbine. So it's a really, it's a really important thing to take into account. The manual handling is a very important part of the training. It's been combined in the last few years with the working at height. I'm not exactly sure why, but the GWO do that sometimes. I can see the idea behind it because working at height, as I say, when you're climbing, you are doing manual handling. You're pushing and pulling and doing various things. There are tools available to prevent manual handling injuries when you're working at height, for example, using lifts. When I started, we didn't have lifts. We had to climb ladders, 60, 70, 80 meter ladders. And we were expected to do that at least twice a day. They kind of had limits. They did set limits sometimes. But that's a big ask. And so they brought in various tools and ladder assists and then lifts are more common now as the turbines have just got bigger and bigger. Sure. So in terms of what we try and do, as I say, it's about teaching the tools so that the technicians, when they go out there, they have the skills necessary to make their own decisions. Yeah. Because we can't simulate every single possible permutation of working at height here. No. You go to a Siemens turbine, it's completely different to a Vestas turbine or a Nordex turbine. And they're all completely different. When you're talking about gearbox turbines, that's completely different to a direct drive turbine. Totally different layout, totally different systems, and totally different hazards in place for working at height. So the industry's changed a lot, but it's continuing to change, and it always will change, and turbines will get bigger and bigger and bigger and bigger. I started off working on a 650 kilowatt Jacobs turbine, and now they're talking, you've got the V236, which is a massive turbine. It's huge. It's the size of 4 shipping containers all stacked around each other. It's massive. So there is a world of difference. And if we can teach those principles so that everyone can make their own dynamic risk assessments, and that's what we try and really push is constantly saying to yourself, am I in the safest position possible? Could I be safer? Could I do something to make myself safer? If I'm, standing over next to the Bombay doors in a Vestas turbine, lifting up equipment into the nacelle, should I be attached with a great big looping fall arrest lanyard, or could I be attached with an adjustable work positioning lanyard to stop me falling in the first place? So it's all about that principle of dynamic risk assessment and reducing the risk to as low, what we term a LARP. It's a very common term in oil and gas and in wind, as low as reasonably practicable. Yeah. And that's the important thing. It doesn't mean you can't do it. It means you can do it if you're careful and if you follow some principles of reducing your risk, basically.
Fantastic. We were doing the evacuation scenarios, coming down with the CRD.
So we're at the top of the wind turbine. Yep. It's on fire, or the lift's broken, or the ladder's broken. Yeah, okay, we just need to get down quite quickly, okay, in a rush. We've got a rescue kit, that one there, this one, okay, they're all the same, they're all concentrated senders. Okay, so the one we were using for the active and the passive rescues, we can use this for this as well. That's a concentrated sender. The first thing we need to do is find an anchor. So you're going to take your CRD here and you're going to clip that up there. I can hold this rope and control your descent through that hatch, or we can just drop.
Let's do a drop.
Go.
Have you got any sort of war stories from the industry of those being in use?
We used to have a partner company in Athens, in Greece, and they were a fantastic bunch of guys, really, really experienced blade repair technicians. They've been working for years. All of a sudden, this is about 7 or 8 years ago, their client demanded that almost overnight they had to have GWO training, right? They're very experienced rope technicians, all IRATA level 3s. And so, knew exactly what they were doing, but the client said, right, you've got to go and get this ticket. So they phoned me up, and I think it was a Wednesday morning. I was in the office, and they said, can you come to Athens tomorrow to give us GWO training? And I said, yes. So I had nothing better to do. So I said, yeah. And I got on a flight at about 3 a.m. the next morning from Gatwick. Arrived in Athens, we drove for a couple of hours, got on a ferry, drove for another hour. And I said, are we near the training centre yet? And they said, we don't have a training centre. We're just using that turbine. Okay, fine. So I started doing the rescues, the basic rescues that you did. They were fine. And I said, well, we need to do a simulated evacuation. So we climbed to the top of this 60-metre turbine. And then we were in the nacelle, and I was looking around and thinking, so who's gonna go first? And they all looked at me. So I said, well, I guess I better go first. They never met these guys before, never seen the equipment, and I'm sitting there on the edge thinking, well, what's the worst that could happen? And then let go, and that was that. So it's not something I'd necessarily recommend doing in anger, because the only real reason you're going to be doing it is if someone is either very severely injured or if the whole thing's on fire. Yeah. And then you need to get out in a hurry. And that's an interesting one, because there are more and more devices on the market, which are what we call personal evacuation devices. Yep. So you've probably seen a few of them. We've got a few examples here. The Cresto SmartLine X, Skylatech Deus 3700, High-Tech Micron as well. There are lots of different devices. That's the situation. The potential is there, but obviously, we try and reduce the risk of that ever occurring as low as possible anyway. So you're never going to be energizing the turbine, re-energizing the turbine when somebody is in the nacelle. Right. Before you go up to the nacelle, everything's locked out. everything is stopped. The turbine's stopped. The blades are pivoted so that they're yawed, so that they're facing into the wind, and they're pivoted out of the wind so that they're not going to turn. When you get up into the turbine, you're going to lock them physically with a big bolt so they can't turn. So when anyone's in the turbine, there's no energy. There's no movement. Shouldn't be any moving machinery. So therefore, the risk of any fire is minimised to as low as possible, really.
Have you seen any sort of technicians go from the training environment to the real world environment? What's that learning curve like? Obviously, you can only learn so much.
Question. Yeah, it's a good question. I mean, what we do here every year is we take on apprentices from Rampion, our local wind farm, RWE wind farm. So they get sent to us for a bit of what we try and call aptitude training, to see how they go. And see how they react to working at heights. You know, can they climb more than 3 steps up a ladder? Are they completely freaked out about descending down into water, into seawater? All of that kind of stuff. And then they go off and join Rampion, do lots of training, and then go off to work. And we've seen them progress over months and years, and they come back. Sometimes and for refresher training. So yeah, I mean, it's a big steep learning curve. But from what I know of the industry, and I've not been an actual technician, a maintenance technician. I've just worked on blades and repairs and various other bits and pieces, internal electrical HV cable change outs and things like that. So not really as a technician. So I what I can see is that they have a very steady progression through from basic technical training to becoming an authorized technician or AT.
Okay.
And that's the progression that they go on. And then from then on, well, the world's their oyster, really, because once you're an AT, then you can travel, you can go off and do all sorts of things. So that's why I'm a bit passionate about the industry.
Yeah.
To be honest with you.
You've had quite a seasoned career in this environment, working at heights, you know.
Yeah.
What other stories have you got under your belt?
Some people might look at rope access as completely different to the GWO working at height. Actually, what's quite interesting when we see it is that we get rope access technicians coming in, even experienced ones, and we do have to teach them really basic stuff when they're doing the GWO. Simple things like climbing a ladder and doing rescues using the control rate descenders that we have inside turbines. Fortunately, touch wood, I've only had to do 2 rescues in my 27-year career hanging off ropes. One of them was a chap. It was my boss. It was Christmas Day 2000. It was 50 meters up a telecoms mast next to a Belgian motorway. And he decided to drill a piece of metal. He couldn't be bothered to go down and drill the metal and go back up again. So he drilled it against his leg and stuck the drill bit straight through his leg. And so there was blood all over the place. It was horizontal snow, if I remember correctly as well. Remember, this is Christmas Day. And so we had to get him down. And the other one, it was offshore. And I had to send a guy down to take some pictures, do some visual inspection. It was about 15 meters down, and he got down okay, but he was a big guy. He was about 130 kilos, not fit, and started climbing back up, and just halfway up went completely collapsed, and said he couldn't come back up. So I had to then haul this guy back up by myself with some pretty basic equipment. And that was a good lesson learned in terms of my supervision, because I realized that I shouldn't have sent him down there in the first place. So yeah, these are all lessons learned. I mean, I have had incidents not happen to me, but I have lost 3 good friends doing this job, and they all died because of complacency. And it's one of the things we try and drill into the trainees is complacency will kill you very, very quickly. Because if you think, oh, it's not going to happen to me, I'm experienced, I know what I'm doing, I've been doing this a long time, I can relax, and that's when it happens. That's when it bites you in the arse, essentially.
With a few new swimming techniques up my sleeve, the next test is getting out of the water and into a life raft.
Probably one of these. And there's like a yellow dangly bit, white dangly bits. Do you want to put your foot in there? That's nice.
Okay, are we all happy, Lou?
Yep.
We'll all get back in the water and then we'll come out.
Great.
How about that?
So we've been doing the descent into the water. We've done the getting into the life raft, working out how to swim around and stay safe in that environment.
Sure.
Are there any more horror stories or kind of anecdotes you've got on this one?
The transfer element of getting to the turbine and back off again is realistically, when you look at all of the statistics and what you're actually doing, it is the most hazard-rich element of your going to work. It is potentially a very, very dangerous thing to do. You're stepping off a moving vessel that's going up and down by maybe 1.6 meters each wave. That's generally about the limit. Each wind farm has their own limit. So it is a potentially very hazardous thing to be doing. And so we've kind of got to try and give some element of realism in there. They've changed the syllabus a lot since I started doing this training 10 years ago, when I got my first accreditation. We used to do, what did we used to do? We used to take people out in a boat and throw them in the sea. We used to have to do a transfer from vessel to vessel and back again whilst the two vessels were going underway. Wow. I'm not sure why they do all this stuff, but they've reduced a lot of the sea survival element of it because of the incidents that have taken place on during transfers. And you've seen during the training, you've seen dozens of videos of when it's gone wrong. And it does go wrong. Not frequently, but it does go wrong. We've had incidents that I know from friends of mine who work in the industry in other places as well, where people have had very, very lucky escapes and got away with it. So it's a really crucial part of the course. As I say, they've taken a lot away in terms of the actual sea survival elements. For example, jumping into water from a height.
Yeah.
They took that out because somebody had an incident in a training centre in Denmark, I believe. They were throwing themselves in from 4 or 5 meters above the water. And so they've taken a lot of that kind of stuff out, which I can see, but and I can also see that realistically around the UK anyway, we've got such a brilliant search and rescue capability that realistically, if you're going into the water off the back of a boat, if your boat sinks or if you're thrown into the water or man overboard or something like that, then you're going to have a helicopter above you within minutes. I mean, we've got one helicopter 15 minutes that way at Lydd. We've got another one at Leon Solent and another 15 minutes that way. So to be honest with you, you're going to be in the pub by tea time. That said, we are sending people out. We've sent trainees out to Taiwan, to Thailand, to North America. And of course, the industry is getting further and further offshore as well. So that element of it, I think, might need to come back into the training a little bit.
Interesting.
Just because you're getting floating turbines, fields of floating turbines going to be coming into operation. And they're further and further in deep water, not on the continental shelf. So that could be an issue. People are actually living and working offshore a lot more these days on standby offshore vessels, on jack-up rigs. So the industry is becoming more and more like the oil and gas industry. And of course, people are taking helicopters to turbines. It's quicker, it's more efficient in some senses. And so the industry will change. I think, it'll be interesting in, say, 10, 15 years, whether we'll look back on what we used to do now, where we've got small boats, relatively small boats, and we're stepping on to the turbine, clambering up a ladder, scampering away from the boat to stop it hitting us, and then scampering back down again and being talked back down. I wonder whether we'll look back and think, what in the hell were they? What were they thinking? Certainly, I've done a lot more walk-to-work systems, walk-to-work jobs that, in my career, where you get the big arm and it's on a self-stabilizing gimbal,
right?
A bit like a flight simulator. So those are becoming more and more common now, and especially during campaigns where you've got a big group of people, a big group of technicians, and they've got a field and they're doing big maintenance jobs on the turbines. So it's a lot more efficient to get lots of people onto the turbine or onto the offshore substation to do maintenance works using a bridge of a big vessel, and things like that. So yeah, that's kind of the industry changing.
Fantastic. On that point, so when you're talking about, the industry's changing so much and there's lots of different things moving at the same time. You've got new technology, so you've got further afield floating turbines, meaning that sort of, the safety measures need to be even more sort of robust to keep people safe in that environment.
Talking about being further offshore, you've got to then think about the medical side of things. If you're not, 10 minutes from land, either by helicopter or by boat, then you need to up your game in terms of medical response. So they'll have paramedics on board on board the SOVs, and they're specialists at doing what they do. So I think that's changing. You're also going to need to potentially have dedicated response and rescue teams specializing in confined space or advanced rescue. And it may even be that, as they've done in the offshore oil industry, in the North Sea, years ago they realized that actually the Coast Guard search and rescue capability, all that was doing was picking up 50, 60-year-old men off oil rigs who are having cardiac events of some sort. Because realistically, they all the ships these days, they're double hulled. They've got GPS, they've got great comms, they've got all the gizmos. So you don't get ships crashing into each other generally. Sometimes you do, but generally you don't. So what the oil industry did was they said, right, we'll create our own private search and rescue capability. So they positioned 2 or 3 helicopters, Merlin helicopters, up the North Sea, so that they were there, ready and on standby, just to do medical evacuations, evacs. So it's that may be how the wind industry goes.
So we've got all these moving parts. You've got new technology with offshore floating wind and the extra safety complications that presents, and you've got the regulators trying to keep up with all of that. And then you've got to think about how the courses and the education is making sure it's still actually preparing people at the end of the day. Yeah,
exactly. That's what the GWO kind of has to always keep up with is changes within the industry. I think what's good at the moment is that GWO has realized that training providers and people who have actually worked on turbines are quite useful, right? Because in the past, what they've had is that their syllabus has been essentially written by committee. And on those committees, you will have someone from Siemens and they'll say, well, we have this stuff in our turbines and this is how our turbine is laid out. We want all of the GWO people to be trained in this way. Right. And then the Vestas guy stands up and says, well, actually our turbines are totally different. We want this to be trained in the syllabus. So you've got this growth of the syllabus. Yeah. And I think what we're trying to push now, and I've been sitting on a working group looking at the working at height syllabus. My manager Miles has been sitting on the advanced rescue working group, and we're trying to kind of, I think, distill the syllabus down so that we can teach the principles, as I said before, and give people the tools to make decisions for themselves. Because most people who work in this industry, they're not stupid. Yeah. Some of them are pretty clever, and they can work out what's safe and what isn't safe You don't need to be an expert with years of experience to work out that if you stand on a exposed edge without any equipment on, you're in danger, right? Or if you bend over and try and lift a really, really heavy thing, you're in danger of doing your back in. So whatever it is, it's about a realistic risk assessment. That's it.
We've all seen the skit from The Office.
Staying alive.
Okay. That was the only reference point besides doing a first aid course with a swimming club a long, long time ago.
Okay.
It doesn't seem to have changed as much as the sea survival aspect has. Is that right?
There are some basics that don't generally change.
Yeah.
But in terms of what we as an industry, the GWO syllabus has changed slightly with more of an emphasis. I think what they're trying to do is push people towards more advanced first aid,
right?
Which is no bad thing as far as I'm concerned. You've got to imagine doing a little first aid course in a church hall or a classroom here or whatever. It's not going to be adequate when you're talking about being 20 kilometers offshore, 100 meters up in a turbine, because basically you're a long way away from any definitive care. The way it's been changing is that they've reduced the basic first aid down quite a lot in terms of the time and the content of it, and increase the enhanced first aid. So I think what they'll do is go towards just having the enhanced first aid.
I think it would be daunting for anyone to have to do first aid in their everyday life.
Yeah.
When we look at doing first aid in the offshore wind industry, what else do we have to bear in mind?
Well, the fact that if you call an ambulance, nobody's going to come. Yeah. So even if you're onshore, you're going to be in the middle of a field, out in the countryside somewhere, and you're 80 meters up, and any ambulance paramedic is just going to turn up and say, well, I'm not sure about that. There have been incidents. There was an incident a couple of years ago where a technician who was commissioning a turbine fell and caused a bad head injury. And I think I read the report, and it took over 90 minutes for the first medic to actually get to the casualty. And that's simply because of where they were. So then you have to be completely self-reliant. And it's difficult. It is really difficult, because we could train people. We could give people a 2-week really advanced first aid course, a pre-hospital medicine first aid course or something similar. But actually, there'd be very little point in doing that because of skill fade. And skills fade in first aid is really dramatic.
Really?
Even 4, 5, 6 weeks after a course, some of that knowledge will have disappeared. Rampion here, our local wind farm, RWE, are very hot on this, is actually refresher training. They do that every single month.
Wow.
So they do a scenario where they'll pick maybe a bad bleed, a catastrophic hemorrhage, or they'll have a heart attack, or they'll have poisoning, or some scenario, or electrocution, and they will run an exercise where all of the teams have to take part and participate. So it's a difficult one, first aid, because like I say, unless you are doing it weekly or monthly or something like that, then the knowledge will decrease dramatically. So when we do our enhanced first aid course, we teach people about airways, about enhanced airways. So things like eye gels, nasopharyngeal tubes, oropharyngeal airways. And that's great, but there's no point really in doing that if you are never going to use it. And you might use it might need it in 2 years' time.
Right.
And then you'll have completely forgotten.
Right.
One way around this is doing refresher training, but actually standardizing things as well is very important. A couple of years in a row now, we've been asked to be judges at a rescue competition.
Oh, wow.
Up in Lowestoft for RWE, big multinational German energy company. And what's been really interesting is seeing teams from all around Europe. So they've had teams from Denmark, Netherlands, Germany, Sweden, and all around the UK. And all the RWE teams in the UK all have exactly the same kit. It's laid out in exactly the same way. So everything is in exactly the same place in the kit bag. So it means that if someone goes from Scroby Sands to Rampion, they will know exactly where everything is because it's all the same. But they will have advanced stuff. They'll have oxygen, Penthrox, painkiller. They'll have all sorts of nice gizmos, tourniquets, defibrillators, etc. We saw teams from, say, Denmark, and they turn up with a little green first aid box with a few plasters in. And I'm thinking, well, actually, their view is that keep it simple is the way to go. And I can see that side of it. I can also see the train hard, train regularly, and you'll be prepared if the worst happens on the other side. So maybe somewhere between the two is a good balance, but we have to train all of those different people. And we have to train them to about the same standard, no matter where they're from or where they're working. So that's quite a tricky thing to achieve in a short training course.
Yeah. Okay.
And certainly for the first aid, you've got a day. The basic first aid is just a day. But what we always do is use people's experience because, if they're happy talking about it, most people have done some kind of first aid. It might be pretty basic. Some people have saved a choking child. Some people have done CPR. But there's always a big mixture of different people.
Okay, so when we summarize first aid, we've got, you've talked about being in the judging a competition internationally, and you can sort of see that there's different approaches to first aid that complicate it, and you kind of want to find a happy middle ground that suits everybody. Yeah, in some way.
I think so. So several years ago, one company had an incident offshore. It was a fibre optics engineer. The tower wasn't in place. They were installing fibre optics and other cabling. And I believe that there was a winch set up for winching stuff into the basement level. And he grabbed hold of the chain winch. At that point, another technician switched the winch on and his hand was pulled into the winch. These three fingers were degloved, as we call it. So the skin was taken off completely. Ooh. Now, that incident highlighted various issues that I think the company then took on in terms of the preparedness of the technicians. Basically, his colleagues were pretty shocked by all the blood and the gore. He obviously couldn't climb down the ladder. And despite the fact that they had the equipment there ready to lower him down onto a waiting vessel that could have shot him back to shore at 35 knots, he was left there for a while until a medic was then brought over, which took at least sort of half an hour from the SOV, and then he patched him up. And then, fortunately, a helicopter was available, a rescue helicopter was available. It wasn't anywhere else. And fortunately, the tower wasn't in place, so it meant that they could pick him up and take him directly up to East Grinstead, which is a world-renowned centre for plastic surgery. And fortunately, they were able to sew his fingers back on.
Wow.
So, a lot of fortunately's there. A lot of luck was involved in that. And I think that really brought it home about how they can prepare for the worst eventuality. So doing these rescue competitions is a really good thing. And it's an instructive thing because it's similar to what we try and do here now in terms of the scenario-based training. Because it's all very well, as I say, splitting it up into, right, today you're doing first aid, tomorrow you're doing fire awareness, and you're not going to talk about first aid at all. Or you're doing working at height, but you're not going to discuss why you're rescuing this person. Why are you rescuing him? Has he, just decided he wants to be rescued? Or has he had a heart attack? Has he slipped and sprained his ankle? Or has he slipped, smacked his head against the ladder and is now bleeding heavily and potentially unconscious? So we try and do all these scenarios so that people can actually incorporate all of the different elements of the training to produce the best result, the best possible result.
Tej was saying Tej was calling it, giving us a a selection of blueprints that we could apply, like you were saying,
Yeah,
dynamic,
it's a good way of putting it. Yeah.
dynamic risk assessment sort of thing.
Crouch down a little bit. Check for heat. Open the door on the hinge side so that the door is protecting you. Get the centre of gravity low and extinguish the fire.
Fire awareness in a turbine, I think we all kind of know what we're dealing with here. The idea that something's caught fire and you're in a confined space. What are we thinking about this?
Well, if you think about a turbine as generally being built in windy places for a reason, they're big and tall. They're a big tube sticking up in the air in a very windy environment. That sounds like a chimney to me. So if you think about what they're made of as well, fiberglass, you've got all sorts of weird and wonderful materials in there. You've got benzenes and phosphagenes and nasty stuff. So I think during the training, you might have seen the pictures and video of the fire at Scroby Sands. That was a dramatic fire. From the first spark, when they were trying to, I believe they were trying to re-energize the turbine, and there was a short across a breaker. And from that first spark to complete destruction of the turbine, of the nacelle, was about 7 minutes, which is seven minutes. Yeah, to complete destruction, engulfed in flames. So if you can imagine, if there were people inside there, they got very, very big decisions to make. So it's that's why you're never in a nacelle when it's being energized. You're never in a nacelle when the whole thing is turning and producing energy. Hot works and things like that are very carefully controlled inside the turbine. One of the biggest hazards is people leaving oily rags and debris and rubbish and things like that. Obviously, nobody ever smokes inside a turbine. Nobody ever vapes inside a turbine or charges their vape in the turbine. That would be unheard of. But seriously, it is a really, really hazard-rich environment. Yeah. So you've got to be extremely careful. We try and talk about, where is the fire extinguisher? Always know where it is when you're working.
This was the thing. Well, the crux of the issue when I was doing the training is the fact you can hardly see anything. Obviously, there's the risk that it will be dark if there's a power outage.
Sure.
And then you've got smoke on top of that.
Completely. Yeah, absolutely. Again, it's something that maybe the industry will have to kind of look at a bit more in terms of smoke hoods or protection or something like that. But really trying to engineer out those risks is the only way to go, really. Yeah. Because if you are really in that environment, your chances of survival are very low, realistically. Yeah. So to prevent that happening in the first place is the most important thing. With first aid, you're always going to have a little knock or some kind of thing. You can try and engineer out that as well, and you can do it procedurally. So you have very strict procedures in place, but remember, we're human beings and we screw up and we cut corners and we think, I'll just get that done. I'll just do this or I'll just do that. Yeah. And that goes into behavioural safety, which is a whole nother issue within the industry and lots of different industries as well. But, in terms of fire awareness and things like that, yes, we teach the syllabus that we're told to teach. They've taken out a lot of the fire, some of the firefighting that we used to do with dry powder extinguishers and things like that, because they're banned in America and they're not really much use inside a turbine because you set off a dry powder extinguisher in a confined space and everything's completely covered and it's a complete whiteout anyway. The engineering solutions that they have to prevent the fire in the first place, halon or other deluge systems, gas deluge systems, those are potentially what's needed, but actually you just need to stop the fire in the first place if you possibly can.
Yeah, fantastic. Yeah. One thing that I've taken away from this course has been that for all the noise and excitement that there is around automation and robotics and things like that, you cannot replace the role of the human being, at least in this day and age, in the wind industry.
A lot more these days, certainly in terms of what I've been involved in terms of blades and blade repairs and inspections, then obviously, yes, you're looking at drones for doing blade inspections. You're looking at high-res video doing surveys of the blades from ground level or from a vessel, absolutely fine. But when it comes down to it, the Mark I human eyeball being up close and actually being able to touch something is still vitally important. So yeah, it's a massive industry in the UK. We're lucky to be involved in it. I'm passionate about it, especially down at our end of the country where we don't have that history of working offshore or heavy engineering. I go up to Newcastle to assess other people's, other training companies' candidates fairly often, Northeast, Northwest, Scotland. And there's a great history of engineering and working offshore that we don't have down here. So I'm really passionate about going into schools and spreading this message that you can have an incredible career and you don't have to go to university, and you can earn more than your headmaster, and you can have an amazing career and travel the world doing this fantastic job. And where do you want to be? Do you want to be in a factory making a plastic widget, or do you want to be 15 miles offshore, 100 meters up in a wind turbine with producing electricity for the national grid? I think that's a no-brainer.
There it is. Thank you so much.
Is that okay?
That's great. Thanks for tuning into today's episode of CleanTalk. If you enjoyed this conversation with Iain, make sure to like and subscribe wherever you're listening in from. It helps boost us up in the algorithm, and we want to get this show seen by as many people as possible. Make sure you're subscribed to the Harmer Visuals YouTube channel so you see the full vlog when it drops this Friday. And if you're interested in pursuing a technical career within the wind energy sector and you want to learn more about this training that's required to do so, head over to belayropeaccess.co.uk today to reach out to the team and see the courses they can offer you. Thanks for tuning in, and see you next time.